Welcome to Learn with Puzzle. Today we're going to be learning about prime numbers and prime factorization. And this is going to be a quick, fun, and easy topic. So before we get into the video, don't forget to like and subscribe. Before we learn about prime factorization, you have to know prime numbers first, then prime factorization. Let's get into the video. Now, what are prime numbers? Well, prime numbers are numbers that only has two factors. So what are factors? Well, factors are numbers that can divide into another number without leaving a remainder. For example, 10. What can get into 10 without leaving a remainder? Well, those numbers are 5 that can get into 10 without leaving a remainder. 2 can get into 10 without leaving a remainder. 1 can get into 10 without leaving a remainder. And 10 can get into 10 without leaving a remainder. So these are the factors of 10. All these numbers can divide into 10 without leaving a remainder. Now, this 10 is not a prime number because it has more than two factors. So a prime number its first specification, it must only have two factors, and those two factors is 1 and itself. So now 10, it has 5, 2, 1, and 10. So it has 1 and 10, which is 1 and itself, but also has 2 and 5, which does not qualify to be a prime number. But 3, let's take 3. What can divide into 3 without leaving a remainder? It's 1 and 3. Only these two numbers can get into 3 without leaving a remainder, making 3 a prime number because it only has two factors, 1 and itself. 5 also qualifies to be a prime number. Let's check it. 5, what can divide into 5 without leaving a remainder? It's only 1 and 5. It's only 1 and 5, making 5 qualifies to be a prime number. And 7, 11, all those numbers, there are a lot of prime numbers. The numbers that are not prime numbers, we call them composite numbers, which is 4 is a prime number. 10 is not a prime number. 10 is also a composite number. 6 is a prime number because 4, what can divide into 4 without leaving a remainder? 2. Also 4 can get into 4 without leaving a remainder. And 1. So this is more than two factors, and which doesn't make it to a prime number. So 4, 6, 8, since they are not prime numbers, we call them composite numbers. Now let's get into prime factorization since you understand prime numbers. So prime factorization is actually simple. Prime factorization is when you break a number into product of prime numbers. For example, let me use 10. So you have to make sure that 10, you must break it into a product of prime numbers. What do you mean? Well, which prime number multiplied by another prime number is going to give you 10. So the 2, which is 2 times 5. 2 is a prime number multiplied by 5 gives you 10. So that's prime factorization. I broke 10 into a product of prime numbers. 2 times 5. 2 is a prime number 5. So that's prime factorization. That's breaking a number into a product of prime numbers. Let's try 8. 8 is not a prime number, but we're going to break it into a product of prime numbers. So which prime number multiplied by another prime number that can give you 8? Well, 2 times 2, which is 4 times 2. So this, you see this one in brackets, 2 times 2. This is the prime factorization. Prime factorization, you're just breaking a number into a product of prime numbers. So I broke this thing into a product of prime numbers. So basically, I said which prime number multiplied by another prime number multiplied by my prime number can give me 8, which is 2 times 2 times 2. So this one in brackets are prime numbers. I can also write it, if you haven't forget your exponents, I can also write it like this. Now, if you forgot your exponents, check my video about exponents in my channel where I explain everything about exponents. So if I use prime factorization on 8, this will be my answer. 2 to the exponent of 3. This and 2 times 2 times 2 is the same thing. If you know exponents, you know this and this is the same thing. That's basically prime factorization, breaking a number into a product of prime numbers. So I broke 8 into 2 times 2 times 2, which is 2 is a prime number. And then, I can write it as 2 to the exponent of 3. This is a prime number. But if I don't want me to use prime factorization on 30, that's what I do. Which prime number multiplied by another prime number that can give me 30? Well, 2 times 3 times 5. The 2 times 3, 2, 3, and 5, they're all prime numbers. So it means I use prime factorization correctly. Let's check. 2 times 3 is 6. Is 6. 6 times 5 is 30. Meaning that if I break it up, if I break 30 into a product of prime numbers. This will be the correct answer because it gives me 30. So, but there'll be some bigger numbers, like, for example, 75. Break 75 into a product of prime numbers. Use factorization on 75. How will you do that? It will take a long time. So yes, a method which you can use. Now that method is called the ladder method. Here's how the ladder method works. The ladder method basically, if like I want to use prime factorization on 75, I write 75 here, and then I divide 75 by prime numbers until there's no remainder. And then after, I'll know how to break 75 into a product of prime numbers. So let me write the prime numbers here. So you must know the prime numbers, you must memorize the prime numbers. So yeah. So now the ladder method, this is how it works. This is I want to use prime factorization on 75. I want to find, like, I want to break 75 into a product of prime numbers. I write it here. I draw two tables and then I put 75 here on this table. Then after, I find the lowest prime number, which is 2. Then I say, can 2 get into 75 without leaving a remainder? Let's see. Well, it can't. 2 can't get into 75 without leaving a remainder. So we go to the next one, which is 3. Can 3 get into 75 without leaving a remainder? Yes, it can. 3 can get into 75 without leaving a remainder. So we write 3 here and do 25 divided by 3, which is 25. Then we check. As you know, when we use this method, we always start with the smallest prime number. So again, 2. Can 2 get into 25 without leaving a remainder? No, it can't. Okay. Can 3 get into 25 without leaving a remainder? Can 5, now we go to the next one. Can 5 get into 25 without leaving a remainder? Yes, it can. So we put 5 here, and then do 25 divided by 5, which is 5. Then we see if 2 can get into 5 without leaving a remainder. No, it can't. Can 3 get into 5 without leaving a remainder? No, it can't. Can 5 get into 5 without leaving a remainder? Yes, it can. Put 5 here. Then 5 divided by 5 is 1. So then after, the number on this side is 75 broken into a product of prime numbers. So basically 75, if we use prime factorization, it's gonna be 3 times 5 times 5. You can check it. 3 times 5 is what? 50. 50 times 5 is 75. So by using the ladder method, we can break 75 into prime numbers, into a product of prime numbers. If you guys enjoyed the video, if you guys understood this simple lesson, please don't forget to like and subscribe, share with friends.